Thank you, everybody, for coming. Can you hear me okay? Yeah. So we'll be talking about CI/CD pipelines. Some of the things that were sort of mentioned here, code pipeline and bash scripts, we'll be covering to a certain extent. What's sort of interesting is that we've had some really good talks over the last few months or so. If you guys were here for the last one that was given by Mike, on the best practices of building serverless applications, this one sort of builds off of that a little bit. So what we'll be doing before we jump into building these into the pipelines themselves is just go over what a real world serverless application looks like. So, you know, we're not trying to create a CI/CD pipeline for a hello world app that does one thing, you know. We want to look at a realistic use case, and so that's sort of where we'll start with. We'll start with what does one of these large projects look like these days. We'll go over some of the CI/CD best practices, but specifically for serverless. So, you know, most of you guys probably have some sort of experience with these pipelines. In other applications, we'll just talk about mainly what are the differences with regard to serverless, things to watch out for, things that you should be looking at. Then we'll jump into CodeBuild and code pipeline. That's the one that I think everybody wants to look at. We'll go over really quickly, sort of step by step, what it takes to put one of these pipelines together based on, you know, given a real world serverless application, given some of the best practices that we want to take control of, essentially. And then finally, we'll look at some of the other options in the space, Travis being a big one, Circle, very popular, and then not so well-known Seed, which is ours. This is sort of what we do, and that sort of leads into who we are. I'm Jay, that's Frank. He'll be talking a little bit later on some of the other sections. We were authors of a tutorial, a guide. It's about 950 pages long now. It started with 350 pages, so it was a bit smaller. And it's, I think, 150 chapters or so. It's grown by quite a bit. What it started off by being was essentially a very comprehensive guide for just like building serverless applications. When people were first getting into this was almost 3 years ago. It was extremely complicated. Sadly, it still is. But because it was so complicated, people almost wanted a way to, you know, sort of screenshot by screenshot, show me exactly what I need to do to get this working. And not just, again, a hello world one, but a full stack application. So it does React on the front end, serverless on the back end. And what we added recently, so on the left here is what we've done so far, what everybody sort of loves. What we've added recently, this was I think a week or maybe 2 weeks ago or so, is what are the best practices for building these things. And again, there isn't a definitive guide out there for this. This is what we've learned from, you know, being in the industry for a while, talking to people, listening to talks like the one Mike gave last time around. And we cover some of these concepts. And so we'll sort of go over some of these concepts in this talk as well. But if you guys are looking for a reference, that's serverless.ym. And for work, this is what we do. This is, if you've got a serverless framework application and you are trying to figure out as a team, how do I deploy to all my different environments, given all these different services that I have, and how do I do that without writing a bunch of bash scripts? This is sort of how we help you do it. Our target is mostly startups, so people that don't necessarily have a DevOps person on staff or don't have somebody that can manage that for them. They've got primarily people that work on their code, and we sort of take care of the rest. So you sort of drop in your project, and it should just work out of the box. And I think we'll just go over that really quickly at the end of the talk, so we won't bore you with the details. Given that, let's get started. Again, this is the talk that I was referencing. This is, if you haven't had a chance to look at this, and I think this is up online already, I'd have to check, but this is absolutely, you know, must read or like viewing. I think the way to sort of think about this is that now that we're almost 2-3 years into even not just our group, but just, you know, community in general, we've got some sort of patterns that are emerging, and there are some good ways to do things. It's not always you get in and then you figure out, you know, what should I do, and you search and you find nothing. There are some patterns out there, and so our talk today is building a little bit off of that. So it's a nice sort of leeway, but it's also one of the concepts that was covered in that talk that Mike didn't get into in too much detail was environments, and so That's something that we'll cover because environments are directly tied to your pipelines that you build. So let's start off by just looking at what a real-world serverless application usually looks like. You tend to have, and again, this is just a little bit of background. So with the service that we run, Seed, we've had a chance now, it's almost been 2 years, we've had a chance to work with a lot of companies at various stages of their serverless journey to get their apps into production. So these are folks that are using our service because they're deploying daily to all their environments using their team. And so now we've had a chance to look at almost behind the scenes what most production apps look like, or what most production setups look like. Just sort of a fun tidbit on the CI/CD side. CI/CD stands for continuous integration, continuous delivery. What's sort of interesting is that a lot of people would like to think that it's like completely automated, but 90% of the cases isn't necessarily so. And again, what we've had a chance to do is almost, again, behind the scenes sort of see what do people really use out there for serverless specifically. So we don't do a lot of the other sort of setups. And so most real-world service applications that we find have got dozens of services, if not 30, 40, 50 services. Again, this is based on the microservice architecture. They are split up into multiple GitHub repositories usually. They've got multiple environments. That's obvious, but they're also deployed into their own AWS accounts. And again, this is something that Mike touched on in his previous talk. We'll go into a little bit more detail about that. And finally, and this one's a little bit more rough, but their development workflow is usually pull request based. And again, we're a little bit biased here because most of our customers and most of the experience that we've had are people that are heavily integrated with GitHub. They're using GitHub as a part of their workflow, and so the pull requests feature heavily as a part of that. But I think the learnings that come out of having that type of a workflow is something that you can apply even if you're not using pull requests as heavily as a part of your team's workflow. But we'll go over that because it's one way I sort of think about it is that people want to get to that state, or teams want to get to that state, and you might not quite be there yet with the setup that you have, but this is sort of the setup that most people are trying to go towards. And just really quickly, a quick definition. Let me just make sure I got the slides right. Yep. Just a quick definition here. When we talk about a serverless application, this is a little bit more specific to serverless framework, but this also applies to SAM and CloudFormation, just in general. An app would be considered a collection of services where a service has one serverless.yml, or another way to think about this is a service is one where you have one CloudFormation stack. So a collection of those would make up the entire app. So, and again, I'll step into details here, but as I'm using the term application, that's what I sort of mean. I mean the overall application, and a service is a specific stack that is being deployed as a part of that application. And you can have multiple things in the stack. You can have Lambda functions, DynamoDB tables, and the lot, but usually you organize them by stacks. And one of the reasons you do is because, aside from the fact that people want to adopt the microservice architecture, so that's like saying, look, I've got an API, and I've got endpoints for the different business functions that I have, and each endpoint is managed by a separate team. And so the microservice applies to that specific portion of the endpoint. That is generally what people like to do, but you almost get pushed into adopting this fairly early because of this very notorious 200 resource limit. Most of you might have sort of run into this. This is when you've got enough of things defined in your serverless.yml or in your CloudFormation stack, you hit a limit of how many resources can be deployed per stack. And so this 200, once you hit it, there are many ways around it, but effectively what you have to do is you have to split up that stack. You cannot have more than 200 per sort of stack. And now, if you haven't gotten into this, you might be thinking, oh, 200 sounds like a lot. Unfortunately, it isn't, because an example I'll give you is if you've got, let's say, an API gateway endpoint, and you've got a Lambda function with it, there's a Lambda function, which is one resource. You've got the endpoint, that's another resource. There's a log group that goes with it. And I forget what some of the other things are, but
Lambda versions.
Right, Lambda versions, and I think you get maybe
IAM.
Yeah, you get maybe 4 to 5 per endpoint almost. So you can imagine you sort of hit that limit very quickly if you've got a lot of endpoints. And again, the one of the other reasons, and this was sort of covered in the previous talk as well, but I'll put it in, is that you ideally want each one of your endpoints to be handled by one Lambda function as opposed to all your endpoints handled by the same Lambda function. And again, this is not necessarily to applies to endpoints, but it applies to a lot of different things. You don't want, generally speaking, you don't want the whole thing to be handled by one function. And so as you start splitting things up, you start hitting this limit. Once you hit the limit, then you start thinking about how do I organize my services. When you think about organizing your services, this is sort of where you get into organizing your repositories eventually. And so now this one is, it's not, one way to sort of put this is generally what we see out there and now what we're sort of recommending most people to do. And I'll get into the details of why this matters or why this is effective. Obviously, you don't have to follow it this way, but a typical pattern that we do is we put most of our infrastructure resources, so these are things that, and again, I'll talk about in detail when we get into the environments part, but maybe things like DynamoDB tables, S3 buckets, like hard infrastructure resources that you necessarily don't want recreating on every new environment. So one way to think about this is, look, I've got a development environment that all of my developers use, but each of my developer or every developer on my team has their own environment. However, I don't want to replicate my database that is filled with, let's say, staging data for them to use for each and every developer. Or I don't want to replicate, if you're using Cognito or something like that to manage your users, you don't want to replicate that information per environment. I'll get into, I'll have a slide that sort of shows the details, but the first repository is usually for things that don't get replicated as much, whereas the second repository is probably one that you're developing very actively on. So this is the one that you're adding new endpoints, you're adding new queues, you're adding new handlers for new events. This is what your developers are working on most of the time. So every time you want to spin up a new environment for them, this is the one that you're going to use to spin up. And again, this will make a little more sense very quickly. Talking about environments, one of the big directives that I think, again, like Mike has sort of touched upon this last time around as well, and we sort of recommend too, is using multiple AWS accounts. Now, this seems a little bit like overkill. This is almost like you're going to create, so your production has one AWS account, like an actual AWS account. Your development has one AWS account. Your staging might have one AWS account. And this might seem a little bit weird, especially if you haven't gotten into this before. But a good reason to do this is because you want to keep, there are a couple of things, but you want to keep as much separation between your production environments and your development environments as possible. So you don't want necessarily everybody having write access to your production environments. And one way to really clear that up, as opposed to manually writing IAM roles that people are making sure that they're keeping up to date, is just create a different account. And this ends up being sort of better because the management tools that AWS has for accounts in general is fairly good. Then the other part, and this is sort of a little bit of a side reason, is that there are certain limits for serverless and other resources as well that applies per account. So say, for example, you've got a development account, and there's one notorious one, which is your Lambda deployment packages. So every time you make a deployment, the package gets sent up to S3, and there's a limit of, I think, 75 gigs. And I think Frank will sort of correct me on this, but per account for that. So if you're doing a ton of deployments, you'll hit that limit. Now, if you're using the same AWS account for both your production and your development, and you end up hitting that limit in development because it's the same account, you'll hit that limit for your production as well. And so in some ways, doing the separation allows you to circumvent some of these limits a little bit. So it's not an absolute must, but it ends up being fairly useful. And again, there are like good tools out there to help you manage some of the stuff. The other quick point I want to make is that you can make a distinction, and this is sort of what I was alluding to before, you can make a distinction between long-lived environments and ephemeral environments or short-lived environments. So again, going back to like the idea of you've got a repo maybe with your infrastructure, and you've got this dev environment with all the sanitized data in your databases ready for testing and whatnot. And you have that set up for your developers. You've got a production one, that's obvious. Now, as your developers are working on new API services, again, I sort of labeled as API service, but it could be anything, are working on other Lambda functions, and they're working on a new feature. So let's call it feature X. You create a new branch. That branch deploys into the same AWS account. So all of the yellow, orange things are one AWS account they all live there. And so you'll have multiple of these. Every time you create a pull request, every time you create a new branch, it'll connect to the same development AWS account for your infrastructure. So this was the point I was making before, is that when you bring up one of these new feature environments, you don't have to replicate your database and sanitize it and have that ready for one of your developers. They can just quickly bring it up themselves. And that's kind of what we want people doing, because the general workflow that we sort of see with a lot of people, it might not be what everybody is doing, but most people are trying to get towards something of this sort because they're deeply integrated with GitHub, is locally you create a new feature branch, you start working on it, you do all of your local testing, and and just like before, you've created a new environment for that the moment you deploy using the credentials that are given to you locally. And then once you're ready, you create a pull request. The pull request, it could be off of, in this case I've simplified it, but it could be off of your development, or you might have a staging environment where you're going to send the pull request to, which is connected to master, let's say. The pull request auto deploys, creates a new environment for itself, sets the whole thing up. You're able to test against it, whether your front-end team needs to test against it or you're running integration tests as a whole. You do that against that because it's running against what would be the closest to production in this case. Once those things pass, you merge the PR. And then finally, and this is sort of what we recommend, this is not quite continuous delivery, is somebody promotes it to production. And we've got some good reasons as to why we think there's a manual promotion step, but just again, just sort of taking a step back, this is roughly what we sort of recommend. And given that as sort of a background, now we'll go into what the specifics of the CI/CD portion is, and again, just for the serverless world.
Hey guys, my name is Frank. All right, I'm going to talk about the CI/CD part. CI/CD, obviously CI, continuous integration, CD, continuous deployment or delivery, what you want to call it. CI, if you imagine CI, it's all the way from the developer git push, right? It notifies the build server fetch the code, you run linting, you run static code check, you run unit test, you name it smoke test, all the other tests. And then at the end of the day, you want the CI server to tell you whether this code is deployable or this code has failed, right? And that hasn't really changed much for serverless. It's still the same, but continuous deployment has been quite a bit different, because before, if you imagine, if you're building a Rails app, deploying it, it's really just zip it up and upload it to the server. And then if you use Elastic Beanstalk, it just EB deploy. If you use serverless framework for deploying like one service, it's just serverless deploy, right? Just one command. So why is continuous deployment like more complicated when we talk about like serverless applications? One of them, like Jay mentioned, is you have a lot more services, and each one takes some time to deploy, right? So what is actually going on behind the scene? Even if you make a little code change, but the CloudFormation has at least a Lambda version change for that. So when you pass that template to CloudFormation, it's going to remove that Lambda version, creates a new Lambda version that points to the new S3 file name that you uploaded. So all these actions take some time, right? For even like a really simple service, it takes maybe 20 seconds to build. And if you have 20, 30 services of them, and it can take minutes, right? We have people that take 20 minutes, 30 minutes for each deployment. And there's an obvious solution to this: deploy all your services concurrently, right? But there's a catch, right? You cannot deploy all your services concurrently because, let's say you have a service called A and you have a service called B, right? And that service A is creating like SNS topic that whenever something happens, it's going to fire an event to the SNS topic, right? You have service B that's subscribed to the topic. If you deploy like both services concurrently, depending on the timing, CloudFormation would kind of fail the second deployment, saying, hey, this SNS topic you're trying to subscribe to, it doesn't exist yet because the first one hasn't been deployed yet. So in this case, you want to deploy service A first and deploy service B. And the same thing applies when we're trying to remove all the services. You have to remove B first, and now you have to remove A. If you remove A first, then again, CloudFormation will be like, hey, dude, someone's still subscribing to this. You can't just remove it. Right? So you need to watch out for the service dependencies. Another thing Jay mentioned is you want like a manual promotion step, right? Because with serverless, or in general with infrastructure as code, right? Like it's really easy to diff the code. You just diff the commit. But what is really happening for the infrastructure code, you don't really know what's happening, what actions CloudFormation is going to take. Like for example, you have a DynamoDB table called users, and tomorrow you want to rename that users to clients. You think, if you come from MySQL background, it's just renaming the table. It's a big deal, right? CloudFormation actually going to wipe out the table called users, remove the table, and recreate another table called clients, right? So and everything seems fine, but when you go to your DynamoDB console, you're going to have an empty table, right? So there are some catches to that. So CloudFormation has this feature called change set, right? So when you change some code in your infrastructure, CloudFormation will compute the final template and show you a diff. And say, hey, when you actually submit this template, this is what's going to get removed, created, and modified, right? So you kind of want to review that right before you push your code to production. Yeah, I can never pronounce this. How do you say that? Ephemeral. Let's call it short-lived environments, right? You have a lot of short-lived environments because Jay mentioned it's cheap, but really it's free. It depends what's in your stack. If you're looking at an API backend, you have API gateway, DynamoDB tables, Lambda functions, even S3 buckets. They're just creating a version of that, duplicate a version of that is essentially free, right? So you want to take advantage of that, and that's exactly what we see from our users, where they, for every feature branches, for every pull request, they create a separate environment, and they give that. Each environment has a unique API gateway endpoint. They can give that to a front-end team, or you can just put it in your React or your front-end app to test it. So one catch is your CI/CD system need to be able to spin up these environments, but more importantly, like tear them down cleanly after, right? So usually CI/CD system, they don't have, they usually get triggered when there's a Git push, or when there's a pull request open, or there's a Git tag, but they're not really triggered when the branch is closed or when the PR is closed. So you kind of need to work around that to be able to say like, hey, when a feature branch is closed, I need to tear down my feature environment. When my PR is closed, I want to tear down the PR environment. Yeah, and again, it all goes back to you have a lot of these services, and teams might have 20 or 30 services, but when they're working on stuff day to day, each commit or each Git push might be only changing 1 or 2 services, right? It's just very inefficient that you go ahead and you deploy all of your services at the same time. This has been like one of the most required requested feature for Seed. So the solution we put forward, but you can use the solution like if you're using Circle or using CodeBuild, doesn't matter what you use. A simple way to get around that is if you can run a git log command, passing in the commit of the previous deployment. That's going to show you all the files that's been changed from previous deployment to this deployment. And then if you look at those files, if there's anything that's changed in your service, hey, I need to deploy the service, right? If something has changed in some common directories, you probably better to deploy all the services then, right? But this algorithm, you can improve on based on kind of like folder directory like you guys are using, right? Any questions up to this point? All right, good. I just see people getting confused. All right, so that's enough theory. Let's take a look at what it actually takes to set up a pipeline using CodeBuild and CodePipeline. Just a very quick background. CodeBuild is a CI service. It falls under the serverless umbrella because it works much like a Lambda function where you give it memory and CPU configuration, and you give it a Docker image and give it a bunch of scripts. So whenever you launch a build job, it's going to launch that build. You launch a build container with a build image with specified memory and CPU, and it's going to go through your build script and manually run each one of them. It's very similar to the build containers you get from Circle or Travis. And pipeline is really like an orchestration tool on top of it. So if you're familiar with step functions in AWS, this is kind of similar to CodePipeline, where it can break up your deployment pipeline into different steps. And each step, you can run multiple jobs within it. A job can be a CodeBuild job, can be a Lambda job, can be a manual approval job. Like the fact that you can run Lambda functions makes the CodePipeline super flexible. You can do almost anything you want with it. Let's take a look at a couple screenshots for the pipeline setup. All right, so first step, you go to our AWS console, the code pipeline console. Just everything that I'm going to be showing that you can recreate every single step using CloudFormation, so you can automate this. But just for this this talk, I'm just going to go through the console experience. You on the right, you just create pipeline. You give your pipeline a name. I'm going to name it master just because that I want this pipeline to be triggered when there's a git push to the master branch. So I'm going to name it master. I'm going to give it tell it to create a IAM role that just give it permission that you can access my resources in my AWS account. I'm going to hook it up to GitHub and pick my repository. And for the branch, I'm going to put in master. Right, very straightforward. On the left, you can see right now I'm setting up the source stage. So they have the source, build, and deploy concept in the pipeline. So a pipeline always starts with the source stage. And then you go through a source stage is really if there's a git push to GitHub or there's a new version of file in S3, you want that to trigger a build. So it's what is triggering your pipeline, right? And there's a build stage where you run your build script. And there's a deploy stage. Anyhow, we're going to get into to those. So this is just defining the source. All right, now we are looking at the build stage. For build stage, right now they support CodeBuild and they also support Jenkins. But for the context of this talk, we're going to create a CodeBuild job. And assuming you're creating blank, you don't really have a CodeBuild project to use. So we're going to select create project. That is going to kick you to the CodeBuild console, where we're going to create a new project. We call it deploy serverless. The reason we leave the name very generic is that we want to create one build job that we can reuse to deploy all of our services. I think it'd be more clear, obvious when I show after we create the entire pipeline, we can see it there, right? We create a CodeBuild job called deploy serverless. You can give it any Docker image you want. The image can be hosted on Docker Hub, or it can be hosted on Amazon container repository. But CodeBuild comes with a couple of default images. And there's an advantage using one of these built-in images is that they come pre-cached on the build server, right? Just like a Lambda where you are not managing a server. So one trade-off you're giving up is for every invocation, you're not guaranteed that you're using the same runtime, right? So same thing with CodeBuild. Like if you're making one build and next build does not guarantee you're using the same host. So stuff like Docker layer cache, they're not guaranteed to be cached. So, but if you're using one of their built-in image, so you can skip all the time you would take to do the Docker pull. So you just speed up your build quite a bit. And then same thing, just like code pipeline, you need to give CodeBuild a IAM role so you can access your resources. And we can tell it that, hey, later on I'm going to create a build spec in my repository. So you could also give a couple of build commands inline, but by all, yeah, it just you give it you define a build spec in your Git repository that we're going to look at after. And you pick a memory and CPU combination that you want to use. There's only 3 options right there. If you're using the 3 gigabytes memory and 2 virtual CPU, you're gonna get that costs about like ½ cent per minute, and you're getting build by minute. And that's it. And you just hit create, and CodeBuild is configured. At the bottom, for environment variables, I'm creating stage and service path, again, because I want to reuse this CodeBuild job. Doesn't matter later on the code pipeline is triggered by master or my beta branch. Like I want my CodeBuild to know that which stage I'm deploying into, and I'm reusing this CodeBuild job for all my services. I want it to pass down which service this job is currently deploying. Right now, I'm just creating a user's API service. I'm passing that me as environment variables. we're going to skip the deploy stage. Because we're using serverless, deploying is actually pretty straightforward. You just run serverless deploy. But if you are using Docker, they have very friendly services that help you kind of deploy a Docker to Docker cluster. That we're going to skip for this talk. It's not required. You review the pipeline, and then by the moment you create the first pipeline, you're going to fetch your latest commit from master and run the build. You can see the build failed because we haven't defined a build spec yet. But before we do that, let's just add the other services in here, right? You can see I added the user service, the post service, and I also have a cron job service in my app. There are a lot of buttons, as normally like Amazon consoles are. There's the add stage, add action group, and there's add action, right? A stage is kind of we saw before. You have a source stage where you define how your pipelines get triggered. You can have a build stage, and you can add any stage you want. And just one stage always gets run, has to finish before the next stage can start. And within the stage, you can have action groups. And again, one group has to finish before next group starts. And you can have actions inside action groups. These are the stuff that can run in parallel. Right? The way we set up like this, it's probably users service is exporting something that the cron job's depending on. That's why we want to deploy cron job after that service user service finishes. So in this pipeline, users and posts are going to get deployed at the same time. After they are done, cron job is going to deploy, right? And then we go to GitHub, we write up, or any Git provider. No, actually, we pick the GitHub as a source, so it has to be GitHub. We add this file called buildspec.yml. We put it on at the root of the repo. It's really straightforward. Just something to mention, you're picking which runtime you want to use. Node 10, the commands, you're installing the serverless CLI. At your root of repo, if you have a package JSON, you run npm install, and you go into your service folder, runs the npm install. Very straightforward. And then you go to your service directory, you run serverless deploy with the stage name. Just know the $service path and $stage are the two things that we pass down when we create a code build. Right. MJ, yeah. Yeah. No.
So you said you're using a standard AWS image.
Yeah.
Ubuntu or what have you. Right. Here you have Node.js. How do we know it's going to be on there? Does that runtime version tell us that we need to pull it right there? What if you have Maven, JDK, etc.?
Oh, right. Yeah.
Sorry, just the question, just for that, it's on the syntax of buildspec.yml, which I'm not familiar with. You're pulling this image, Ubuntu image, as a standard image. How do we know Node.js 10 is going to be on there? What if you need other tools like JDK or Maven, etc.? I just want to understand how that part works.
Oh, yeah. That's for the, we're using one of the managed image. It runs on Ubuntu, and the image used is actually a built-in image called AWS/CodeBuild/standard2. And that's a polyglot image where it's like 5 gig in size. It comes with Node, different version of Node, different version of Ruby and Python and Java and PHP. So it comes with everything. And what they do is in your build spec, you say which runtime you want to use. Right, so like after the build server start, you're gonna look at your runtime versions, and it's gonna say, okay, I need to use that. Let me bind the node binary to version 10, pretty much. Yeah, you can specify multiple in there. You can have, I want Node 10, I want like Ruby X, I want Python Y. But you cannot go, I want this and this if two are conflicting. If you want like a Java version, and I think they also support Android version in there, if you say Java X and Android Y, and if those two doesn't support each other, and they're gonna throw in build error. Yeah.
I think my answer to me is,
yeah.
This is what do you call it, a mother image.
Exactly, yeah.
Anything you could possibly need.
Yeah. It has like all the, like a lot of like programming language in there built in, yeah. Hi, go ahead.
Can we use the existing Jenkins or build servers instead of using CodeBuild or code pipeline?
Yeah, you could, yeah. I think you can, Yeah, when you're creating your build stage, in the build provider, you can select CodeBuild or Jenkins. Yeah. Yeah, I haven't tried it. I don't know what's required to set it up, but you have the option to use CodeBuild or Jenkins in there. Yeah, yeah.
Yeah, the big difference. The big difference really is that with CodeBuild, it's sort of the serverless. Like you're getting billed per minute that it's running. Like you don't have to run the. Like in the case of Jenkins and the other sort of, and we might look at the setup really quickly, is that typically the server is running and you're paying per concurrency for each server that you have running. Whereas here you get charged for as you bring it up and then you turn it off, you're just going to get billed for the amount of time that was getting used for. Yeah, it's open source. Yeah. You'd have to run it on your servers. You're paying. No, there is service online. Oh yeah, that too. Yeah.
Basically, you can bypass this CodeBuild. But currently, if you want more agents, more concurrency, you need to pay more. Yeah, but for one, it's good.
Yeah. For Travis, you're saying?
Travis CI.
Oh, for Travis CI, yeah.
There is a website. If you have one
Yeah.
job, it's free.
Yeah.
And you can bypass your CodeBuild.
Right.
You deploy over there, put the keys, and it will build your job, and it will be deployed in Amazon.
Right. I think Circle definitely give you one build container for free. I'm not sure about Travis, but if it's free for open source, yeah. Yeah, for sure.
Yeah, so I mean, I just wanted to ask, what are the advantages or disadvantages of using the big image versus using very specific image that you have that you require for your stack?
Right, if you bring your own image, I think how it works is when you, let's say, you launch a first, you make your first build, and they're gonna spin up a build server, and they're gonna do Docker pull. They go to wherever is hosted, they're gonna do the Docker pull, and they're gonna spin up the image. It's probably take 20 seconds or like 40 seconds, depending on the size of the image, right? If you use and say that build is finished, and your next build start, it might or might not be on using the same build server. If it's not, they're gonna go through the Docker pull again. So at the worst scenario is every single build, you're gonna get hit with that 20 to 30 seconds build time delay. But if you use one of their built-in ones, the image is already cached on the Docker layer, Docker cache layer. So like the launch of the build container is gonna be really quick. Yeah. Cool. All right. Yeah, go ahead.
In the example, you are using one mono repository to multiple services for the example of the linting. But in the best practice, you say it's not necessary a best practice that.
Yeah, I'll address that after.
Yeah.
Let's go through presentation questions.
All right. No worries. Yeah. All right, so yeah, this is the what it looked like. At the bottom, you have a cache. Just very straightforward is you tell CodeBuild that after each build, cache my node modules so that next time when it runs npm install, it will be much quicker. Yeah. Sorry. All right, so the moment you git commit and git push that build spec, or when you git push anything, that code pipeline is gonna get triggered. Right, over here you can see that users and posts have successfully deployed, and the cron job is deploying in progress. So that's the ordering that we are talking about. And you can click into any AWS CodeBuild job. If you just click on AWS CodeBuild in every single block or click on detail, it's going to show you the build log. And over there, if you've tried it before, it's very similar. That's just the output for serverless deploy. And the end is spitting out the API gateway endpoint that I just deployed to. Yeah. Yeah, pros. This I always recommend like code pipeline, CodeBuild to people if they want to go completely AWS. It just makes their life much easier. That for security reason and everything runs in your account. If you want to turn on artifact support, they store it in your S3 bucket. Cache stores in your S3 bucket. All the build logs are in your CloudWatch account. So everything sits inside your AWS account. And because the code job over here, you see we have users code build and code build job and post code build job. You can add Lambda jobs in there, right? You can do whatever you want. You can, let's say, after over here, you can add a Lambda job saying, you're going to send me a text message saying, hey, users and posts are done deploying, right? You can add another job there saying cron job is done deploy. You can really do anything you want. So it's super, super flexible. And it's probably the cheapest CI option you're going to find, because a code pipeline is like $1 a month for each pipeline. And you get one free, and CodeBuild, you get like 100 free minutes per month and half a cent per minute. Right, but it's super complicated, and just look at the stuff that we went through. You have to tie a bunch of AWS services together, the IAM stuff, the S3 for the cache, CodeBuild, code pipeline, and yeah, like it's require a bunch of AWS knowledge for you to be able to set something up, and it doesn't. And again, like I mentioned, it doesn't know that when a branch is if you are if you go back, what we did is we set up a pipeline that tracks our master branch, right? That track our master branch, right? You cannot do a catch-all, right? If you want to set up for an alpha branch or a beta branch, right, you have to create one pipeline for each, right? That's the downside, and so it's not really feasible if you require some sort of programming if you need, or some custom code if you want to like enable the feature that, hey, when there's a feature branch, automatically creates a pipeline for me. Yeah, and same as PR flow. Right now, code pipeline cannot be triggered by pull requests, but because everything is in AWS, everything's so flexible, you could create a Lambda API gateway endpoint that add that as a webhook for GitHub. That gets triggered. That Lambda function creates a code pipeline, and deploys a code pipeline, and then you have to create a pipeline for your pipeline, right? And right now, it doesn't support Bitbucket or GitLab. So there are some limitations. Like gentleman mentioned, there are other options. Like Travis CI has really good Git workflow, and it only supports GitHub, but it supports GitHub amazingly, and it's free for open source. But one big problem is how they run is you pay, I think, $70 per build server. You pay $70, they have one build instance for you, right? If you want to deploy 2 services at the same time, you need to pay twice that cost to be able to deploy concurrently, right? If you have 20 servers, that you have to pay 20x. Depends how much, what's your max concurrency you want to deploy it with. And it requires a lot of manual setup to be able to be like, hey, I want to deploy only the services I want to deploy. I only deploy the services that have changed. All that require a lot of manual setup, and it doesn't really support when you close a branch or close a PR. It doesn't really automatically remove the get triggered and remove your serverless service. So there are some tricks around it, but it's required manual setup. Another popular service like Circle CI, super flexible. It has this concept of you can break into steps, just like code pipeline. You have stages. Inside stages, you have job groups and you have jobs. Circle have something similar to that. Again, more flexible pretty much means you need some sort of scripting, and yeah, again, you pay for concurrency and require some sort of a manual setup for CI.
Yeah, and just really quickly, I'll show you a couple, literally 3 screens with what we're doing. But to address that question, yeah, maybe I'll go back here really quickly. So the question was, how come we're doing a mono repo when clearly the best practice says that you have 2 repos? Sorry about that. But the way we sort of, again, these aren't obviously hard guidelines, but usually what we end up seeing is people splitting up their repositories in terms of infrastructure and the stuff that they're using for their day-to-day development. So this API services section, again, just all Lambda functions in general, that is typically a mono repo of all the different services that they have, of all the different Lambda functions. So you'll probably hit a limit even within there, and then you have to start organizing that. Whereas the infrastructure one, it depends what you have. In some cases, you might just be using Lambda functions to talk to your existing infrastructure. You might not even be using, serverless or infrastructure as code to bring up your existing infrastructure, right? This is, This entire thing is assuming that the whole setup that you have is done through serverless. It doesn't have to be. Again, maybe you're just managing Lambda functions, and that is typically monorepo. And so yeah, so there are different variations of this. Some people are sort of against this. They're like, no, I want to do everything in different repos. You're free to sort of do that. A quick guideline though is that if you're going to split up your services across repos, which many people do, you would end up doing something like, in the case of Node, you might have a private NPM registry to have NPM modules. Essentially, you're trying to share code across repositories. So that's the question that comes up, is that if I've got multiple repositories and I've got 2 of these services and they have some sort of common code, how do I share that common code? And again, different philosophies. Maybe your team is large enough at one point that the common code really needs to be managed almost as a separate NPM package that your team is then consuming. In that case, then yeah, separate the 2 services into different repositories, take that common code that you have, manage it as an NPM package that gives out its own version updates, so you can have different services using different versions of the common code library that you have. We generally end up sort of recommending, again, we're working with sort of smaller teams and startups, so we end up recommending start with the monorepo, put them all in one repo, just shared, because it's a shared directory within the repo, and you're fine. Once you hit the point where you're like, oh, 2 different teams are managing some of my services, and I can't make just wholesale changes to some of the common code or the libraries that I have because it'll affect everything, then you begin to pull them out and you manage them separately. So, but the general concept still applies. Like you're going to have multiple services dependent on each other, and you have to figure out sort of a good way to manage that. Again, yeah. Yeah.
So as you mentioned, there's this private NPM repository.
Yeah.
Any recommendations? What do you see in the world outward? What people are using, Verdaccio or something else? Or
Yeah,
or
I don't.
Private, they just pay for private NPM.
Yeah, that's usually what we end up seeing. Yeah.
How about Python? About pip repositories?
I haven't. Yeah, I'd have to look into it. I'm not quite sure. I know Node pretty well, and that's what they end up using. It's usually like the biggest question we get is, hey, I've got a private NPM repository. How do I use it with what you guys are doing?
This is what I was looking into as well. Another short question.
Yep.
If you have a private NPM repository, do you see people starting it up or just having it running all the time, or having it just start up of that repository integrated into build to save on money, or just people don't bother?
Yeah, I think you might have to talk to Frank about this one. But as far as I know, it's what they're usually giving us is the token for referencing that private thing, and then we just sort of pull it for them. But we don't use that internally, so I'm not.
Yeah, I just had a question going back to organizing. As you start to build all these policies and you run different things like ABs and so on, what's the best practice for organizing your YAML files?
Yeah, so this is horrible. One of the biggest problems people run into with serverless and just YAML in general is it's notoriously bad at just managing some of this stuff. And so in a lot of cases, what people do is they just start splitting and including. So they would have one big, in the case of serverless at least, they've got one big serverless YAML, and then there are portions of it that they take out from somewhere else. So say, for example, you've got like 20, 30, or 40 lines of YAML to bring up a DynamoDB table. You have that in a separate YAML file somewhere else that's included. Those are some of the basic things that people do. The move that we're seeing now more of that we're beginning to explore a bit more is it's called AWS CDK. Some of you guys might be familiar with it. It's basically, because what's happened now with CloudFormation and some of this YAML is these are just like incredibly verbose, right? Like every single thing is defined really meticulously. It has to be because it's infrastructure as code. But as a developer and even as a DevOps person, you don't necessarily have to deal with every one of those things. And so something like CDK is gaining a lot of popularity, where it's actually as code, so as JavaScript code. And you're going, I want to create a new DynamoDB table, and here are some defaults that I want to use. When you run that, it will spit out the bigger YAML file. So you're not actually touching that YAML file anymore. You're just dealing with the JavaScript, let's say in this case. So I personally think that is the direction that people are going to move in. Because if you think about what serverless is in some ways, and what you think, or when you look at Sam or some of these other guys, they're really just abstractions on top of the underlying CloudFormation, because nobody wants to deal with the underlying CloudFormation template, right? And I'll show you really quickly one of the things that we do with the change sets as well. Same sort of thing, is that people don't want to deal with that. They're creating layers of abstraction on top of that so that they don't have to write it personally. I don't know if that exactly answers your question, but yeah.
I was heading more towards, do you organize it based on the type of service, or the dev team that's running that service? Like, how do you split that up in terms of just internal company organization? Because like what's happening is, like, for example, if you have a break or something goes wrong, somebody at some point has to go through a certain set of YAML files to figure out what actually happened and why did it happen. Somebody made a change, and we got to figure out what that change was because it's buried somewhere. So like, what's that organized? Like, who's like, do you just throw everything on the DevOps guy and say, hey, it's your thing, or?
So per service, let's say like you've got a team responsible for one area, that thing has its own sort of YAML file that's self-contained. So we don't end up, if we go back to, I guess, I have to run through, give me a second here. Yeah, so if we go somewhere here, inside each one of these environments, you have multiple services. Each service has its own. So when it breaks, like let's say the CodeBuild, like the logs that Frank was showing, when it breaks, you know that service is broken, and the entire application, this whole thing, we're not dealing with that as a whole. So you're not organizing your entire application under one YAML file. Even though it's still, like, even an individual service is still quite large, it's a little bit more manageable. So when a build job fails, you know this service has failed in this environment or whatever, or in this branch, and you can go down and look at what the definition for that one was. And again, you end up organizing that as well, and so it breaks up a little bit more, but it's still self-contained. So this thing really quickly, an application is like a collection of these services, but each service has its own. So hopefully that makes a bit more sense. Like per service, you get one YAML file, basically, as opposed to like the whole thing. Yeah.
I just had a question. I'll speak loud enough. Just stepping back a little bit, this seems like a new model and paradigm for developing applications.
Yeah.
I was doing a tutorial, and I think it mentioned, like, here are some websites that are already using it. If you could, maybe for the group myself, what are, like, is this new paradigm lend itself to certain types of applications? How complex can the apps get? Can we just start taking, like, really heavy duty, like, United.com websites and start making them all serverless? Or what are some of the more successful candidates out there that are good use cases for why to go down this road?
Yeah, definitely not United. I don't think I'd recommend that. But the pattern, a lot of people end up, and again, I think this depends on, so two big sort of patterns we notice. One, with something like United, maybe you end up seeing teams that are adopting Lambda functions specifically for events tied to their existing infrastructure. So there's something going on in my existing infrastructure, and I need to do some computation based on that. So you know, that's sort of where it would come up, as opposed to what they traditionally do is, like, you'd have to start up another server to do some sort of tiny job that you want to do. So Lambda ends up being really, really good glue code in that scenario. When you've got a massively complicated infrastructure and you want to deal with specific things that are happening within there, that's where we see a lot of adoption in sort of the enterprise world. Then there is the other group of people. These are the ones that we're more familiar with. These are startups, smaller size companies that are trying to move in the direction, this is a bigger bet, is that their entire, or at least 80 to 90% of their infrastructure is purely serverless. There's some advantages that come with that. Some of the things that we talked about, where environments are basically free. You can stand up, tear down anytime you want. Every developer gets their own isolated environment, things of that sort. And so there are companies that are betting on that because they're going, look, eventually I think everything else is going to be serverless. Might as well start now. So those are the two general patterns. Obviously, if you're a much bigger shop and you've got a lot more existing infrastructure, going wholesale doesn't make a whole lot of sense. One adoption pattern that they tell you is maybe break off a specific service. So if you're really, really big, and now I'm thinking about adding this new service, maybe I'll experiment serverless in that instance, as opposed to thinking about how am I going to translate? Because you've probably read this and you probably recognize moving it over, there's no lift and shift, right? There is no such thing as like taking a United.com and 3 months later you've got it in serverless, right? It's going to be, you have to rethink some of these patterns, and the patterns are different. So those are the two big things that we sort of see. Before we jump into the rest of the questions, I'm going to give you a quick spiel. Can we see this? Yeah, actually we can. So this is what the dashboard in Seed looks like. What this really is pretty much what we sort of talked about. You've got one big repository here, aptly named monorepo. You've got a bunch of services way on the left. You've got a bunch of environments that are grouped into all my development things. They're probably on one AWS account. You've got staging, another AWS account. Your production, another AWS account. The PR stages are ones that are these ephemeral ones. And every time you open up a PR, this thing will sort of come up. And we've got this sort of promote flow, which is, so let's say I go in here and I go, look, this thing looks ready to me. Let's promote that. That looks tiny. But what this is the change set that we were talking about. This is, again, all we're doing is we're comparing, and you can do this with CloudFormation change sets. You're taking the CloudFormation template that this environment has and comparing it with, in this case, staging. So I'm going to promote it to staging. What does staging have right now? And just compare those resources. We do some smart little things because we have a general idea of the resources that you're trying to move over. And there, again, like we mentioned before, there are tons of these resources behind the scenes. We know that most of the things that you want to look at is probably, oh, I'm adding a new Lambda function. I'm adding a new API gateway endpoint. And all the rest of them, in this case, we're just hiding it for you, and you can sort of expand them to sort of see. But again, the point is, look, you've got a good view of what is getting promoted, and then you sort of go ahead and promote that. The other thing that we do, again, we already talked about this, is once you go inside one of these builds, there's some concept of deploy phases here. There's some reliance of one service on the other, and so they need to go after that. So the first group goes concurrently, the second group goes concurrently, but they go after the first group. And finally, the check marks are basically just symbolizing that, like, in this specific deployment, some of those services weren't updated, so there's no point deploying them. But yeah, that's really just it. So the difference for us and our pitch to most startups really is, if you want to go manage your own infrastructure for your CI/CD pipelines, you're welcome to do so. In our case, you would need no scripting. We follow some of these guidelines that we talk about, and we do them out of the box for you. It doesn't work for everybody else. Again, not recommended for United.com, but for a startup, I think it works perfectly fine. And that's about it, really. Let's go back to questions and networking. Yeah.
So basically, there is another cloud provider which is developing sort of functions.
Yeah.
But you can warm up. Let's say you can say, I want 3 functions to be all the time up. So Amazon is moving in this direction with some product because the serverless right now is on event.
Yeah.
You trigger, let's say, 30 second late, you have. But now if you have, let's say, 5 functions, which is all the time up, you can get the hit, and you have no this time, and you can really make a very nice website static with functions. So Amazon, do you know that they developing something?
Yeah, so the direction that they're going, I think you're talking about the cold start, like it takes some time to start up. Is that what you're saying? Yeah.
No. Yeah, maybe Amazon has exactly this. Because Google is the other provider which is right now.
Yeah.
To release something like this.
Yeah, I'm not entirely sure what you mean, but I think you mean like.
It's very nice. It will be if you're in the business and have all the time.
Right. Yeah. If you can tell us about what the service is, because I'm not too familiar with Google.
The name of the service.
Yeah.
I was in Google presentation.
I see.
And the guy working for here in Toronto.
Oh, cool.
And he said they're developing right now in beta stages.
Yeah.
A couple of functions, and you can take, let's say, this much request. And on top of that, they're developing one function can get more than one request.
Oh, wow. Okay.
So you're expanding in this way,
Hmm.
and then you hit, let's say, 70% of CPU, and then you start in 30 seconds later, you have another function, and then you cool down.
I see. Yeah, yeah. I'd have to check it out when they release it, I guess. Yeah, cool.
I have several three questions
Yeah.
that are linked between in mind with the velocity or speed of development process, because you said about the ephemeral stages
Yeah.
in development, but I think is I don't know, load a whole cognito or a whole DynamoDB for each developer for each
yeah,
pull
yeah.
request
Yeah.
could consume your time.
Yep. Yeah.
Yeah.
That's a good point.
So, and also you say about the build efficient build deployment
Yeah. Yeah. Yeah.
using cache. Yeah, right. Using
Uh,
cache in the build spec.
Yeah.
files.
Yeah.
Caching,
Yeah. Yeah. Yeah.
Sorry.
Yep.
So, how do you invalid the cache when I want to add new modules, for example, in Node.js?
So for the first one, yeah, this is exactly it. I think you want to split up your ephemeral environments and your long-lived environments. So let's say, like, yeah, bringing up a cognito and it takes a really long time. That's one way to think about this. I would maybe move it over there, right? So that every time a new feature is being developed and we create a new environment for that, we don't need to create a new instance of your cognito user pool, let's say. So that's one way of separating between these two. So what we're trying to say is, especially in the case of the database, yeah, every time you create a new database environment, you're probably going to replicate the data, sanitize the data so you can use it. You obviously don't want that for every single feature that somebody's creating, right? So that's the way we would separate those two. Just keep the ones that can be deployed very quickly in this one repo and have all your developers work on that. For the caching one, so in the case of the cache, what that's really doing is, let's say you did an npm install on one of the services, right? And it created the node modules directory. You can say that I want to cache that directory. And right, so the next time around when I do an npm install again, most of these things, if you've got a lock file set up properly, then it won't do most of this install. So usually we don't see people invalidating the cache unless they have an error of some sort in the build process. So it's not very common that you have to invalidate the cache. It can happen sometimes, like, say for example, like, you were deploying, maybe you were like testing with another pipeline, or you were testing it locally, and now the cache is completely out of sync. That might be a case, but usually you don't end up invalidating unless there's an error. Yeah.
How do you manage secrets?
Yeah, secrets is a good one. So this one, I would recommend the talk from last month. I think there's a link and he'll share it, but very quickly, it's SSM is the sort of recommended way now. So this secrets manager is another one. So what this is doing is you're storing the secret in the AWS console, and you get it when the Lambda is invoked. So when your function is invoked, it will decrypt the secret, and it'll keep it around for further invocation. So that is the recommended one. So that one they do. This actually runs inside your code itself. So this one's a good point. So typically when we think about secrets, we think about secrets as being something that happens at build time, and that's partly what we recommend in some of the other tutorials that we have. But now they're moving towards a recommendation, and again, it's up to you. You can use a little bit of both. The way they kind of think about this is for really secrets. You want that, you maybe want that decrypted at runtime as opposed to build time. So this is, as your function gets invoked, for the first time it gets invoked, it will go decrypt it, and every next sort of invocation, warm invocation, it will have it. We still recommend using a little bit of both for, again, like really sensitive stuff, put it there and have it done at runtime. For most of the normal things, what most people are used to, just do it at build time. In this case, so it would be a separate step. I'm actually not familiar exactly with, how would you put the secrets in the build step?
Oh, in the build step?
Yeah, in the code build, I guess.
I think Yeah, there are different ways. If you are using a serverless framework, I think in the serverless.yml, you can define, hey, I want to load, okay, Lambda functions, they have environments, right? You can define Lambda environment variables in your serverless.yml. And when you're defining them, you can be like, hey, I want to define this environment, and this environment should reference the serverless, the SSM parameter, right? So when serverless is doing serverless package and serverless deploy, while that serverless is going to go to your SSM console, fetch that thing, decrypt it, and then put it in as a Lambda environment. So during runtime, you can just do like, if you're using Node, you can just do process.env. You have access to that variable, yeah.
So this is basically the exact same thing that I was saying, except it is, instead of decoding it at runtime, you're decoding it at build time. It's done automatically through serverless framework in this case. The sort of, I guess more, not quite traditional, but like the way that most people are used to is, in the case of Circle or Travis, you set up your environment variables there, or your secrets there in their console, and that'll be made available to you as a part of your build process. So that would be an additional step in some ways. So a lot of different ways to sort of do this, but
Or if you're looking at the build spec, it's really just bash script, right? You can, and you have access to the AWS CLI. You can just do AWS CLI. You can do AWS SSM decrypt this variable, and then that's gonna give you the return of value, and you can use that in your build script however you want. Yeah.
Yes, I have a quick question, and thank you very much for this talk. My question, I'm only curious, do you plan to do with your product to do the same thing with Azure platform, with Azure function?
Not quite yet. We're still going, there's still quite a lot to do with AWS, but eventually, yeah, probably.
Okay.
For now, mostly AWS.
Thank you.
Yeah, pretty much, yeah. No, that's exactly what it is. We can't quite deploy the whole thing because it'll break, but, but we deploy most of it.
So my question is, how many pipelines you will generally need for one project like this? I guess you will have two pipelines, there, one product. So you will have two serverless files, right?
It really depends on what service you're using. If you're talking about code pipeline, unfortunately, like for every branch you want to deploy, that you have to create a separate pipeline for it. As I said, there's no like catch-all. You cannot set up code pipeline like anything, any branch get pushed to. I want to have my pipeline triggered, right? You can't do that right now. It's like in our setup, our pipeline only get triggered when the master branch is pushed to, right? So if depending how many branch you want to track, you have to create that many pipelines. And you're gonna do that for both repositories.
Yeah, the advantage is just that it's very flexible, so people end up doing crazy things like what you were saying before. They have pipelines that create pipelines, and so. I haven't looked at that yet, but I mean, you can do the pipeline, yeah, just in CloudFormation. I don't know if CDK has it just yet. Yeah.
So I have a question actually more related to your product, like C. So how could we set up a new project, like using some sort of like infrastructure as a code approach, like in your product? Because you just like show the, like have like already set up one, right? So if we want to set up from scratch, so how could we do that?
Yeah, so we make some assumptions here. We're assuming that you're already deploying this through serverless framework. So if you've got a working serverless framework application, just point the repository to us. And that's essentially what you end up with. I mean, I can show you really quickly. I don't want to bore everybody else, but let's see here. There isn't a whole lot going on. It's fairly straightforward. When you add a new application, you're asked to pick up from your GitHub, where your repo is. You pick some services, just like what we had shown before. By default, we help you configure a couple of environments, and if you've got it set up before, you can copy it over, and then that's it. And then you end up with the pipeline, essentially. Yeah. So, but again, this is just maybe to answer your question a little bit better. It's you have to have that portion working first. You have to have, a serverless framework application. Our product doesn't help you do that. That you have to sort of do with serverless framework. But if you have that working, then we can take over. Yeah.
So, quick question. Right now, we can use C, which is hosted by you.
Yep.
And that kind of doesn't work for a lot of companies.
Yep.
They don't want somebody else to be in charge, like something is stuck, it's the middle of the night, it's going to be hard to reach. Is there a version where we buy it and we host it ourselves?
Not quite yet, but so this was one of the things that I think the advantages portion that Frank was talking about. Like, it's exactly what you're saying. Sorry, just quickly. This is sort of obvious, but one of the big things that we get from a lot of people is they want everything to be run within their account, basically, and that's something that we're thinking about at some point, but not quite yet. I think it's, behind the scenes, what we're doing with Seed is sort of cobbling together a bunch of these services and putting it together. There isn't a clean pattern just yet. I think we'll get there pretty soon, where you've got these templates, basically, right? Like that you should be able to start up in your account that brings up conceivably the entire thing that Frank was talking about that we set up. And yeah, so not quite yet, but.
Seed gives a lot of advantage, like setting up CloudFormation, CodeBuild, and everything is not as easy. It's time consuming, and the biggest thing is they don't support Bitbucket directly. You can't use code pipeline. You got to use separate CodeBuild, and
Yep.
set it up. It's a bit messy.
Yep.
So that's one thing. But again, thinking about it from a company perspective, I wouldn't want my pipeline to be in somebody else's hands.
Yeah, it totally makes sense. Yeah. The other version that we've sort of looked at, and maybe at some point we're going to do this, is that the console might be hosted on our side, but all the resources, everything runs on the company's account, and so yeah, it's definitely a thing that we get.
So you mentioned when you were introducing your company that the goal was to eliminate DevOps people. I want to dig into that a little bit. Is that
right?
Is that, would you still recommend one head of DevOps just in case something goes weird, or do you stick by the fact that if you use your system and your platform and you're offering that, the startup that you're working with can only have engineers and developers?
Yeah, it is actually a good point. So the reason why we started doing this was because the pattern that we noticed, and we've done this internally, and I'm sure anybody that's run a startup or a small business based on anything dev related has sort of run this. If you're the technical lead of the company, you're the DevOps person, basically, right? Like, and that goes on until like maybe you've got like 10 people, and at some point it's like it's a breaking point where it's like, oh, I'm actually just doing bash scripts, right? Like, that's my day job now. Every time you need a new environment, bash script. So our goal in some ways is to be like, look, we'll do the running part for you, and the downside of that for us has been that we end up doing a ton of support work for a lot of startups. A lot of it is just pure AWS related. So just today, I had somebody that was asking me about some weird, build error. And again, these are like very cryptic errors that if you're the technical lead of the company, now it falls on you, and you're going, I've never even heard of the service that we're using, but it's giving me a problem. And so, at least for the companies that we're working with, we actually end up being the point of contact for most of the issues that they run into. One of the things that we're working on, this is a bit of a sneak peek. The issues that we're finding are there are just tremendous amount of problems with just setting serverless stuff up, and it should just be a lot easier. Partly because we're bombarded by these support issues, but also because I think we're like 3 years into this journey, and it's still quite hard to build large-scale serverless applications. I'm sure you guys can attest to it. So at some point we want to do something about it.
What's your stack if you build your site and where do you deploy it?
Sorry, what's that?
Your site.
Yeah.
Operations, where do you deploy? What is the stack that you
It's completely serverless. It's like CodeBuild. We don't quite use code pipeline, or we didn't because when we had started using it, it was fairly raw. They're still adding more things to it. Like even to put together this talk, I think within the last sort of 3 weeks of when we had written all of our blog posts, there have been some changes. So that's when we had done it originally, we decided not to go with code pipeline, but CodeBuild is quite solid. That team that runs it is doing a pretty good job as well. So our entire setup is completely serverless. Our recommendation is, if you're doing anything where you've got just tons of these services and you need to deploy them, I would really consider looking at something like CodeBuild. It's basically the serverless version of Travis or Circle, right? It's like, you spin it up just for the build job. You can spin up as many as you want. Like in our case, you can sort of think about this. We've got at any given moment, you're running like 400 or so concurrent jobs because each one of our users probably has like 40 something services, and and that's getting deployed concurrently, and and it does really, really well. So internally we're completely serverless. Most of our stuff is run on CodeBuild. We do have some container stuff as well, but again, like brought up by ECS, that sort of thing.
So I have a question about best practices.
Yep.
So my impression so far was, and from the presentation and from your website, that the general recommended approach is if something changes at the infrastructure layer or at the library layer, then pretty much you deploy all the services, right? Sometimes it's not exactly what you would like to do, right? At least, immediately. And you know that your library layer or infrastructure layer affects only a number of services, a small number of services. So any advice on how to do that quickly, or any approaches, or any way to define partial dependencies or temporary strong dependencies?
Yeah, eventually I think, especially with libraries, because it's a little bit different with the infrastructure case. With the library case, it really, I think, and I was sort of talking to this before, is that you get to a point where you want to decouple. So let's say you've got two different services using a library that, the moment you make a change, because you've got some change to make that you think is going to affect one service, but actually it's being used by both. And you don't want that to happen. You want to decouple that to the point where it's like, keep using the older version. I'm going to deploy the newer version just for this one. At the end of the day, that is the limitation that you hit, and that's probably the best way to do it. And this is why people end up having the libraries managed completely separately and being deployed separately as well. So the NPM route is one that we see basically people doing because that's the limitation that they hit, and they don't want the tight decoupling. You don't want to have this problem of like, I'm going to roll this out and it's going to touch every single service that we have in one go. Yeah, that's probably the best way, I think, to do the dependencies. For the infrastructure part, one of the reasons why we sort of recommend handling them a little bit separately is you want almost, at some point at least, you want somebody else in charge of doing that. So like bringing up a new environment, or the part that we didn't quite touch on, which is a big topic on its own, is, what do you do in the case of a database migration? Like, what do you do in the case of you've got a new table or a new index or whatever that you want to add? This is something that you want done and Frank can speak to this, but you want it done in phases almost. It's that, I think maybe you can explain quickly on that one. Like if you're bringing up a new table.
Right. Let's say if you, for some reason, you want to rename one table to something else, right? You cannot rename the table. Or let's say you want to change your primary key on your DynamoDB table, right? You cannot change your primary key. You have to bring up a new table, right? How do you do that? I think that the first step is, bring up the table, empty table, and you're still writing to the old table. Now change your code to write to both tables, right? And then as you're writing, your code has, and at the same time, you're going to run a background script that's going to migrate the data from row by row to the new table. And you have to make sure your code handles both cases where the data is writing it might exist or might not exist. So after this entire process, you're going to shut down the code to only write to a new table, and then deploy a change to your infrastructure stack to drop the old table. Right? That's
that's pretty much why, I think on some level we recommend this pattern of, I'm trying to scroll up again, but this pattern of splitting them up is almost, you're splitting up responsibilities. A lot of the developers in your team don't necessarily have to worry about, the database portion, unless, of course, they're making a database change, in which case, it has to be sort of orchestrated through multiple phases, like sort of what Frank mentioned. So we prefer to separate that on some level.
Very quick. Have you guys actually seen CDK working in production? I tried it a year ago. It was horrible.
CDK, I think, so what's interesting is that because it's just spitting out CloudFormation, the reason I think, it's still, I'm quite sure it's still in beta. I don't think it's been sort of recommended. The reason I sort of mentioned is because eventually I think that is the direction it's going to go. And I don't think anybody wants to manage YAML, right? Like that's just not,
Do you, are you seeing that startups are making the choice to go to AWS versus like open source, like Istio, in terms of like going, we don't want to be dependent for the rest of our life on, because like this is a lot of setup to finally get going, to build all your YAML files the way you want it.
Yeah.
And then you can't make a switch for infrastructure later, right?
Yeah, you definitely can't. Yeah, I think for startups, eventually, it's funny. It's that I think we were talking to Mike again, the speaker last time around, who deals primarily with startups. Is at the end of the day, I think startups just end up picking what they're comfortable with on some level. So it's the technical lead. What was he using the last time around, and they end up going with that. The serverless switch is a little bit more interesting because I think for startups, it makes more sense if you start by thinking about it as a whole, as opposed to making a switch halfway through. So either you commit, right, and be like, look, this is what we're going to be running until we're the size of Instacart, right? We're just going to be on AWS until we get to that size. And then we'll think about moving parts of it out. Typically, it's like, I guess, a move like what Dropbox did at some point. They just wholesale decided, yeah, we're going to go somewhere else because of cost reasons, or whatever else they decided with. So that's sort of what we see. It's like either they pick and they go, look, for our foreseeable future, we're just going to be here. Or there's somebody else that comes in and they've had this experience in the past where they're going, no, I want to have this ability to be cloud agnostic. And so I want to run on something open source that could run potentially on any one of these providers. And with Kubernetes, I'm able to abstract that out. A little bit of both, I think. Yeah, eventually, if I was to talk to somebody else that is trying to make this decision, I would go with, do the thing that gets your website up and running within 30 days, like, Okay,
so for example, like, so a lot of companies have like mixed models. Like they'll have a lot of their containers or servers running on Azure, and then if they need to do a call to a service, for example, like a Lambda function or whatever, I mean, the only thing you have left is just to use a generic REST API. I mean, that's all you have, and there could be latency because you're going back. I mean, there's just all kinds of issues, and it's kind of like, so you got the open source, then you got Microsoft, and then you got, Amazon. It's actually a harder decision if you're thinking about what's going to happen in the future in terms of like where you're going to park your containers at.
Yeah, containers are a bit different, and obviously you see with this case, it's like you're deeply tied to the provider. You're making performance choices, architectural choices, everything specifically for the provider in this case, opposed to the container.
So we have to leave this place in 25 minutes. So final questions.
Yeah. So I wanted to know more about the problems you guys had, if any, with cold starts, because you just mentioned that you guys use serverless for everything, which is great, but whenever you want to take a look at this is the thing that comes up first, because if you're building a web app, you don't want a cold start, which takes like a second. So what are your experiences with that?
So there are obviously startups out there that have specific requirements for some of this. In the financial world, this obviously is never going to fly. But for us, you've sort of seen our product. To a certain extent, we're okay with putting up a certain amount of delay. That said, there are, again, best practices, which I don't understand why this is not sort of out of the box. But the general recommendation that we find, and Amazon is continuously getting sort of better at this, like year over year, if your package, the package that is deployed for a Lambda function, is under the size of, let's say, 5 megabytes or so. Again, this is a rough sort of hand-wavy answer, but if it's under that, then the cold start is sort of manageable. We're talking about like 200 to at least like sub 300 ms. This is Node.js. Node.js is a little bit faster than some of the other environments in their cold start. But again, your sort of mileage might vary. This is something that at least they think they can get it down. Their bet is that eventually they're going to get it down to a point that it is applicable to 80% of the websites out there. Is it there yet? I would say almost to the point that we can use it, and most of the companies that we work at can use it. We do use a combination of like some of these warm-up plugins that are out there, which is they just ping your Lambda so often. But mostly with the amount of uses that we see, it ends up factoring in very little in terms of the total amount of requests that are impacted by the cold start. But again, you have to do a little bit of work, so you can't just throw your entire application and expect that it'll come up in 100 milliseconds, you know? So there's a little bit of optimization that needs to be done. Another thing that just doesn't get talked about for some odd reason is that you should be packaging each one of your functions individually. And there's a certain pattern that you want to adopt with that. You don't, when people first get into serverless, they throw their entire Express app or Rails app, conceptually that is, into a single Lambda function. That doesn't quite work. You're going to be hit with a much larger cold start. So packaging each and every single Lambda function. And there's a little bit of optimization again that you can sort of do around that. You know, don't package the AWS SDK, it's already there. Things like that. Like you'd have to work at it to get it to an acceptable level. And we've sort of gone it down.
How do you handle canary deployments with this?
There are a couple places where you could do canary deployment. They support, again, like because every single service is run by a different team at AWS, so each one have support kind of out of the box. With API Gateway, they have a canary for different version of API, right? And for Lambdas, right, you have Lambda versions where every time you push your code to Lambda and they tag a version on it, you can say this version I want to route like 90% of the traffic to, and the other one have 10%. Again, if everything is behind Route 53, they have their version of canary deployment. But again, it depends on like your use case, right? If you are building like API endpoint, maybe the best choice is to use the API canary deployment. But if you have a lot of like cron jobs or a lot of step functions or Lambdas triggered by SNS, maybe you can use a Lambda versioning for that. Yeah. Oh yeah, and for the deployment, they have a code deploy service that you can use. You can specify in your CloudFormation template, and Serverless Framework has a plugin for that. So every time you deploy, you can say, hey, my Lambda functions, I want to shift 10% of the traffic every 5 minutes to the new version for the next 100 minutes or so. Yeah.
Any more questions? So maybe big thank you for the presenter. And then thank you. We still have a draw to do. Thank you so much. So you're going to have recording and the slides very soon. You're not going to wait another month like the last time. Anybody that did not receive the raffle ticket from Manning, Shelly, can you show the books? Anybody? No? Okay. So, Jay, you want to do the honor? See who won.
6904035. So 4035. All right, we've got a winner.
Congratulations. Congratulations. So think about the titles we have. The last one is the video course. I cannot say good enough things about the Manning, from Spring in Action from 2 decades ago to these data science books. You just load them up into the Fire player and enjoy. And this is the video, the last one. So come here. So thank you. So we have 20 minutes to mingle, and then we'll be out and hopefully see you next month. Thank you for coming.